In this video, I'm going to show you how to use the Cart Disturbance module in the Control Theory Virtual Lab. Each module uses a PID controller to control the position or path of a specified mass. The cart disturbance module consists of two equal pendulums connected to a cart. The cart is connected to a rack and pinion, which is actuated by a random signal generator. This causes a random disturbance which affects the pendulums. One pendulum is PID controlled, and the other is free response. When the folder is downloaded, all the necessary files are included. The folder consists of the Control Lab SLX file, 13 step files, and 2 data file mat files. For the module to work correctly and load all the necessary solids, all the step files must be on your MATLAB path. This is achieved by either having all the files in the same folder and opening it as your current folder, or by manually adding the files or separate folder those files are in to the MATLAB path. If the files are not on your MATLAB path, this error will appear when you try to run or update the simulation. To select the cart disturbance module, click its blue title, then double-click the now highlighted box. In this window, you can change the length of the pendulum rod and the mass. The Position Scope button opens a graph which shows how much the pendulums rotate in degrees in response to the disturbance versus the simulation time. The PID Control button opens the PID controller where you can change the proportional, integral, and derivative constants. You can either change the constants manually or use the Tune button to let MATLAB calculate the values. Make sure that Select Tuning Method is set to Transfer Function Based. Click Apply at the bottom of the window, and then click the Tune button. Once the window loads, simply click the green arrow button at the top of the window to update your PID controller with the new values. Then you can click Apply and run the simulation. Once the simulation is finished, you can use the Position Scope button to compare the movements of the controlled pendulum versus the free pendulum. You can also save the simulation data in your MATLAB workspace to compare it to other systems. For example, I'll change the P, I, and D constants. Click Apply and run the simulation. Now I'll compare the response of the controlled pendulum with my values to the response of the controlled pendulum using the tuned values.